So this week, I ran across an article by Nginx, where good company, owned by F5, also another great company, where they were talking about how we can improve your API scalability. Now, Nginx portrays itself as an API gateway in a lot of instances, and API gateways cannot measure your scalability. They can measure your architecture as a whole, but they can't measure the scalability of your API service. It's like trying to measure the speed of your car using a radar detector from, another state. um, or I don't know. Because the API gateway is a service completely removed. Now, what they are effectively measuring is the speed of the entire architecture. And when they do that, there's I/O between each individual service, and there are redirects and things like that. And so, who knows what they're measuring when they're not putting a daemon on each individual service, detecting each individual redirect or the I/O in between and things like that. It's impossible to say what you're benchmarking here or what you're profiling. So, and I mentioned that to them. I said, you're measuring architecture. You're not measuring API scalability or API speed. That API speed there can be anything. I mean, if somebody wants to fix the way something routes, they're going to have to talk, um, change their AWS service, or they're going to have to talk to their DNS routing, or a million different things. It's not based upon Nginx at that point. So they they didn't do anything. They didn't change their article as per usual because it was written by an evangelist and a marketing team, and they don't care. They have product to sell. So I decided this week I'm going to do an article on profiling and benchmarking again, and really dive down into how to profile and benchmark your API and what that should be and what all these statistics and everything mean, and to get a good benchmark on your API, and how to profile your API and what the difference is between profiling and benchmarking. So let's go into that and let's start that episode. Okay, so today we're going to start off with talking about benchmarking. Now, I'm going to be using a tool that I built based off of Apache Bench, which is a really good benchmarking tool, and I call this tool BAPI Bench. Now, the BAPI Bench, which is based off of Apache Bench, shows a whole series of tests, and Apache Bench allows you to only do one test. What I did is I extended this out so that you can do a whole series of tests, using concurrency and number of requests, so on and so forth. Now, you don't have to set concurrency, you don't have to set the number of requests, so on and so forth. It will use a base concurrency, a base number of requests, and a base test num if you don't set those. But if you want to set those, it will work just fine. Oops. And this is what I used for my test. Now, I'm not going to run the test here myself because I'm using video and video recording equipment, and this really sucks the processing power, so that I can't do the test and this at the same time. It will truly affect the test. This is one of the things that you have to keep in mind. When you're doing a benchmark, do the benchmark without anything else. Otherwise, you're going to affect your test. So I ran the test, I ran the benchmark, and these are the results that it will spit out. It will look something like this in your file. And I'm going to run through some of these statistics. I mean, it will tell you the URL you used, the concurrency, the request, the number of tests. Hardcore tells you whether there is a pause between each test. Now, the reason we put a pause between each test is because usually in any kind of when your site is getting hit, it is not constant traffic. There are pauses between the traffic. There are little burps in the traffic. It is not constantly being hit. a million things of traffic constantly. There are little burps between traffic. It's just natural to get little burps, and so we put in little pauses. But Hardcore just takes out all pauses and is a constant stream of traffic. And that will show you how it will respond if you get a constant stream. And that is, Hardcore is like for if you're Google. And that will show you how that's going to respond. Content type is how it's responding back. And document length. Now, this is something that people get confused with. Document length and transferred request. And I think I just changed these two to be a bit more clear. Document length is the actual resource that is being responded with, the actual JSON resource that's being responded back with, and that's 112 bytes. But the full amount of data that is being transferred back, headers and all, now that's transferred per request. That's 307 bytes. Now you'll notice that's a huge difference between those two. Just the resource versus transferred request, 307 bytes. Now, 307 bytes is what's actually being transferred. Big, huge difference. But some people will only report the 112 bytes. Yeah, not the same thing. So we're actually transferring 307 bytes with every single request. And we're doing 3,000 requests per test at a 200 concurrency, and we're doing 50 tests at that request number and concurrency. And you'll see how it, in this first test, how it scales up each time, starting off, and this is from a dead stop all the way up to about each request taking 0.28 seconds each. And the full number of requests down here, you can see all tests took up to 80 seconds, so we can do 50 requests and 3,000 requests, so that's 150,000 responses in 80 seconds. And scaling all the way up to about 36,000, somewhere around there. And it tops out around 3,500, and our 75% cap is around 3,000. And so that's where we should cap this off for our load balancer and everything, saying 75% so we don't overheat these suckers. Down here, we can see what the traffic is and everything. And usually the connection time for something like this, you can see is, and I forgot what I surmised this connection time thing was. Waiting and processing are the exact same number, you will notice. And so waiting is effectively no more than just waiting on processing. So this number is pretty much the same every single time. Processing is, the connection time, this is just usually due to threads being used. You're maxing out the threads for the time. And so this is about the time that it starts spawning new threads. And you'll see it takes care of this pretty quickly and scales on down. So this is a pretty good number, which is why I set this to 203,000, so I could show you how it ramps up pretty well. I've played with a lot of numbers here to show how this ramps up and how this scales. And over time, if you benchmark this, you'll see how this ramps up. And I do this on local host too, not over network, or not out at the API gateway. I'm testing only on local host. So I'm reducing my I/O overhead so I can really see how the API server scales, not how the entire architecture scales. I want to know how the API server scales. You can test how the other components scale later and configure their I/O and the load balancing and everything for that. But this is to test how your APIs scale. And this is what this is all about. Also, another big thing that really drives me crazy is that when people are doing benchmarking, they're only testing an API world. They're not testing security. They're not testing caching. They're not testing pre-processing, post-processing, etc., etc. When you're doing a benchmark, you should be testing all of this. This is why let's see, go back here. This is why I put token into this as well, so that you can pass a token and test all of this. You should be testing every single aspect of this when you're setting this up. It should be a full benchmark. Otherwise, you're testing nothing if you're just doing a hello world. Yeah, and I think that pretty much covers every aspect of benchmarking. If you have any questions on this, please post them to BAPI Bench, or post them on the video here, and I will gladly answer them. But let's continue on with profiling as well next. So, one of the other things I wanted to talk about today is a profiler. Now, the profiler differs from a benchmark in the fact that it walks through and it shows the time it takes to, at every single method or function in every single class, the time each method takes in processing time. So you can actually see which method or which class is actually taking the largest amount of time, or which method it is actually hogging all of the resources. So you can look for the bottleneck in your API service to find which methods or which classes are actually causing the biggest bottleneck. And this is actually really, really useful to do. And I'm actually going to show you here really quick what this looks like, because we actually built this into the BAPI API framework as a tool. API benchmarks actually show you how you are scaling, how you are doing, and API profilers show you where you need to improve. So these two tools together are very important in helping you to improve and better build your API. You really can't do without either one of these, which is why I built tools for both. So there you go. I just picked an instance and an endpoint and formatted the data to call it. And you can see here, it shows every single one of these methods that are called in the classes. Profiler com process and profiler com process afterwards. I haven't added in the controllers yet, because each individual controller, you would have to put in the time for all of these. And that can add overhead to your controllers that I don't want to have to add. But I may grab this from logging at a later date. But right now, I can grab these from the filters. The filters and the interceptors, this information, which is very, very useful. So I'm grabbing this from the filters and the interceptors to be able to calculate a lot of this information, because the controller data is very, very minimal. But you'll see 0 to 6 milliseconds, 6 to 7 milliseconds, 7 to 31 milliseconds to create that, the cache and the cache hash. Check URI definitions, get method params, check off, And then in here to convert the model, again, we're taking the domain or the database tables, and we're converting that to something that we can use as JSON. Also caching that, and formatting the domain object and returning it. Now, this is the very first time this is called. After that, we cache it, and it is immensely faster. This, we're just saying, is it a cached result? Okay, grab it from the cache, format it, blah, 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 blah. And after that, again, even faster. This time it's 4 seconds. And again, 4 seconds, 2 seconds, 3 seconds. It just gets faster and faster every single time because that cache and it spawns new threads. The cache, it realizes there's less to do because it's understanding how to better process the data. It has stored a lot of that data in cached results, and there are newly spawned threads. And so every single time you do this, you'll see that it just gets faster and faster and faster and faster and faster and faster. Sometimes you'll even get this to where there's no processing because every single thing that you did is cached and ready to go. Or all the processes are less than 1 millisecond. So you'll get something like that, which means it is very optimized. This is as optimized as you can get it if you've got it so that you can get responses that are less than 1 millisecond. But this is a very optimized setup if you're seeing things like this. It's a good way to test it, and especially testing it live as well. Very, very good thing to do because then you can see it with traffic as well, how it's doing. But having this tool, a profiler, as well as a benchmarking tool to be able to see any bottlenecks, that's your profiler, as well as seeing how well it will scale, minus your architectural pieces, are two very, very important tools, but two very different tools for seeing how well your API will perform. These are two very different performance tools, mind you, but they both are very well in helping you to see how well your API performs and how well it can scale and remove all your bottlenecks and improve the performance overall. So I hope this was really informative and helped you out overall in seeing what you can do to improve the performance of your APIs. And if you have any questions, as always, go ahead and post them there or post them in the forums for BAPI as well. And I'll see you next week. Take care.